so it's shiny, which is kind of cool. Light cool front for us. It's been very hot, very dry here in North Florida. BE8AP K4QDN. Yeah, QSL. I've been thinking about taking the XLL and my youngest daughter to Florida.
The important role that coaxial cable plays in amateur radio frequency transmission should not be minimized by beginners. In their journey through the many aspects of amateur radio, coaxial cable is essential to the formation and transmission of electromagnetic waves that carry our signals around the world. Equally, the type and quality of the connector applied to the coaxial cable is also of importance to this process. This video is not intended to explore the many aspects of different types of coaxial cables, but instead focuses on the elements of cables and connectors that amateur radio operators require for successful signal transmissions. Coaxial cables are electrical transmission lines used to pass high radio frequency (RF) signals from one point to another with low signal loss. Coaxial cable has many applications, including phone lines, cable TV, internet, cell boosters, and most importantly amateur radio signals. Coaxial cables come in many sizes and lengths, each designed for specific uses. As you can see from the image, there are four main parts to a coaxial cable. Number 1 is the center conductor. Number 2 is the dielectric insulator. Number 3 is the shield. And it is all protected by number 4, the jacket. At the core, coaxial cables consist of a single copper or copper-coated steel wire. It's what carries the RF signals. A dielectric insulator, often made of plastic, surrounds the wire. It keeps a constant distance between the center conductor and the next layer. The metal shield made of woven copper, aluminum, or other metals, wraps around the insulator. It cancels outside electromagnetic interference. Some coaxial cables are constructed with multiple shields for extra protection. The final layer is a jacket that protects the whole configuration. Its rating lets you know where the cable can be installed. Coaxial cables transmit signals through the center wire. To ensure a quality signal travels the length of the cable, a metal shield is needed. Both components receive a current simultaneously, generating a magnetic field. This allows the signal to remain intact and not bleed out like it would without the shield. The metal shield also helps protect the signal from electromagnetic interference. Thus, coaxial cables can be placed near other electronic equipment without any issues. For optimal performance, the distance between the core and shield must be consistent throughout. The dielectric insulator makes that happen. It also prevents the two signals from coming in contact and canceling each other. All components are further insulated and protected from damage by the outer jacket. As a result, RF signals can be carried over long distances with little interference or loss. In amateur radio use, the signal is then converted into images, audio, or digital signal formats. When selecting a coaxial cable for amateur radio applications, you will want a cable that is rated at 50 ohms. Amateur radio operators have a wide variety of options. As it relates to size and price, the issue that arises for the operator is the loss rating of the cable. The higher the loss, the greater the reduction in signal strength. Loss can be decreased by factors like antenna height and antenna transmission quality. High-frequency radio communications became an integral part of the history of World War II, where communications over very long distances became critical to military units. UHF connectors were developed to make it easier to connect radios to antennas and other components. As military communications needs increased and radio technology advanced, PL259 connectors were developed. The design of the PL259 increased the frequency range of the connector. The PL259 connector became the choice for amateur radio operators because it allows for impedance matching between components. Impedance matching ensures that signals flow seamlessly with minimal loss or disruption between various components. The PL259 connector is composed of three parts: the plug, the receptacle, and the center conductor. The reducer allows for a smaller size coaxial cable to be used with the connector. The connector that mates with the PL259 is the SO239 connector. The SO239 connector is mounted on the back of the radio to permit the PL259 connector and cable to attach to the radio. It can also be found on extension and transition cables, allowing for the connection of various types of components. As we conclude this video, I hope this has provided you with a basic understanding of the type of coaxial cable and corresponding connectors amateur radio operators rely on for communication purposes. Using the right cable and connectors always pays off with great contacts.